Good. Great. Thank you for inviting me to the conference. I've really enjoyed listening to the paper so far this morning. So I'm going to talk about a paper with Chris Nielsen and Seth Zimmerman, where we look at how students think about earnings and outcomes after college and how that affects their choices for which college and major to enroll in particular, what measure the impact of earnings disclosure or information disclosure on the part of the government on shifting beliefs and enrollment decisions. And the motivation for this work came from large increases in the rate of student loan default in the US in the 2000s. Obviously continuing to today large increases in the rates of student default and also cost of college and size of loans being attributed for decreases in marriage formation and childbearing and home ownership and a whole bunch of things. But at the time when we started working on this project, they were in particular the source of protests in Chile and also in the US. And this paper is going to take advantage of data in a field experiment run in Chile. They are the sources of protests by many students over the burden of student loans. And in the US, a lot of work has been done to understand where these large increases in student loan defaults have come from. Looney and us have a really nice paper showing that it's kind of driven by a small number of institutions and degree programs in the US, mostly non-selective or for-profit providers that enroll a large share of low-income students. And one common policy approach to ameliorating what we might think are mistakes and choices, particularly among first-generation students, is disclosure. So the idea is to inform prospective students about outcomes. Government might collect data on cost, debt earnings, and past student outcomes. And these types of broad disclosure policies have around the time or after the time of when we implemented this policy with the government of Chile, were implemented in several major developed countries. One reason that you might favor disclosure over regulation is that it's cheap and easy to implement. So it's easy to put information out there, but to a large extent, the benefits are going to depend on what's causing individuals' choices and how that's related to beliefs or preferences, and also how helpful or believable or credible the information is. And so what we're going to do is use a large-scale policy experiment and survey in Chile to ask and hopefully shed light on the following questions. What are students who enroll in low-performing degrees thinking about as far as earnings and costs go? What are their beliefs? How are enrollment choices affected by an actual disclosure policy at scale? On the student side, how does the distribution of expected earnings change and why? And on the institution side, which types of schools and programs might be most affected by disclosure policy? And what we're going to end up doing is in Chile, we worked with the Ministry of Education and the Office of the President to design data that measured returns to college, labor market returns to colleges and majors in Chile. And I'll describe how we do that, and the paper describes it in detail. And then we essentially created a field experiment where, as part of the student loan application process in Chile, we randomly assigned essentially 40,000 students to receive a disclosure treatment where we provided them access to that information for colleges that they were choosing and also for all colleges and majors in general. And so to some extent, this disclosure policy should be, if anything, more powerful than kind of in the short run at least, than posting information online, because it is happening at the time of decisions, that decisions are being made, and there's kind of a guarantee that the student has to see it and acknowledge it and understand it. And so I'll talk a little bit more about that when we get to the details of the experiment. So our key findings are as follows. First, as part of this field experiment, when students had to, when they applied for their student loans, they had to essentially complete a short 5-question survey, and then they were either put into treatment or control group to receive this additional access to earnings and employment information by college and major. And in this survey, we actually ask them, before they're given this information, what their beliefs are about earnings, which programs they plan to enroll in, and what their beliefs about earnings are for themselves and for others like them, particularly at the programs that they are planning to enroll in. And so what we find from the survey data is that beliefs are kind of linearly related to observed earnings from colleges and majors. Students enrolling in low earning programs and typically coming from low SES backgrounds tend to overestimate the earnings that they're going to get over not going to college after graduation by about 140%. Students enrolling in high earnings program underestimate earnings slightly. And we argue that this is kind of consistent with a Bayesian model of belief formation, where people know kind of the average earnings benefit from getting a college degree, and then maybe have some noisy signal about a specific college or major, but particularly among low-income students, they tend to attribute to all of the colleges that they could get into, which are lower performing colleges or lower value-added colleges. They attribute to them essentially the mean outcome across colleges, as we'll show, and that tends to drastically overestimate. They have an overestimate coming into college as to what they'll be able to earn afterwards. And the experiment essentially is going to affect poor students choosing low earning degrees the most. So this disclosure that we're going to give them to show them kind of actual data that is taken from tax records. This is going to affect poor students the most, although it's also not going to have a gigantic impact on them, as I'll show, or it's not drastically going to change their decisions. It's going to reduce their enrollment in kind of the bottom tercile of programs measured by earnings outcomes by 3.3 to 4.6%. It doesn't end up pushing them towards lower cost programs. And we're also going to look at how those students do once enrolled in these colleges, and we'll show that the low SES students end up staying in school longer. We don't quite have enough data, or not far enough along in time yet to look at actual graduation outcomes, but the low SES students are going to stay in school longer, and the high SES students are, if anything, going to graduate a little bit sooner. And what we're going to conclude is that essentially students learn from the intervention, particularly coming from low-income backgrounds, those coming from low-income backgrounds. But at the end of the day, they really care about other things aside from income quite a lot. And so disclosure, doesn't quite move demand as much as one might hope. And it does move enrollment slightly down for for-profit programs in fields, questionable fields is kind of how we put it in the intro. So you might think of like a 2-year degree in journalism, or 2-year degree in baking. So it tends to move students away from those fields, the disclosure does, but doesn't do so a ton. So at the end of the day, it may be the case that if there are, still serious, persistent differences in beliefs and actual outcomes, and that those are binding once students have to pay back loans, you know, regulation may is a more blunt instrument, but if you really need to move demand, that it might be what's needed.
Justine, I'm going to break my rules again because I see you're on slide 4 out of 31, and I'm.
Oh, it's not really 31 because
Okay.
I chopped out a bunch of slides for this, so don't stress out. Yeah, I think I'll get there. It's not 31. I took the longer version of the slides once we knew we had 20 minutes and chopped out a bunch of them from the PDF that did not update the numbering. All right. Okay, so what does the higher education market look like in Chile? So the market structure is similar to the US and other Latin American countries in that there's public subsidy as well, public schools as well as private schools. It's similar to the US in terms of share of the market, meaning share of students graduating high school who go to college. And the important difference is that you apply to a university and a major combination as opposed to just a university as you do in the US. University major applications are very common in Europe and Asia as well. And the way that the application timeline works is that in November, you're going to fill out the FAFSA, which is, the FUS, which is the equivalent of the FAFSA, to apply for financial aid. In early December, you take an admissions exam like you would in many Asian or European countries. In January, you learn the score and you apply, and in March, the new school year begins. And as part of this admissions process, for many students, they'll be given one admissions ticket because it's a centralized process. So the intervention is going to be part of the fall 2012 application process. It's nested within the financial aid application, this FUAS application, and we had access to all applicants. Essentially what would happen is the students submitted the FUAS application, they received an email from the admissions authority from the Ministry of Education, and they were asked to participate in a brief survey and directed to a link, and they were kind of encouraged to participate in the survey as part of their student loan application program or process. Then essentially they're going to take a brief survey, and then they'll be split into treatment and control groups, arms at random. And the intervention that we're going to show them kind of resembles the US college scorecard data in the sense that they're going to get information on earnings, and they're also going to get information on this earnings for a bunch of degrees. How are we going to calculate these earnings? Essentially what we did is we used earnings data from the population of tax records linked to administrative education records that we did this down in Chile. So essentially we have the universe of all college applications and enrollments. Actually, there are a set of papers on this that went back to like 1980. We use all of those data linked with high school graduation records, and we link those to tax records. We're going to use that to essentially create earnings measures for each college and major, the value added to earnings controlling for observable characteristics. And as part of the treatment, we're going to first ask individuals what their expectations are. So first, we're going to ask them where they're planning to enroll in. We're then going to ask them what they expect the total cost of attending that degree for a year is, and then we're going to compare that. We actually have that in the administrative data. And we're going to ask them about what they expect to earn once they have a full-time steady job after graduating, We actually wanted to do enrollees, but the government partners were very adamant that we use graduates. So we're going to benchmark that also to earnings for graduates for 1 to 2 years post-completion. And the treatment that we're going to give them is essentially a monthly payment associated with the cost of the college degree paid back over 15 years, which is the typical student loan payment term, and also the monthly earnings over the first 15 years of a career based on these tax records. And we found that this monthly kind of earnings frame and cost frame was the easiest for students to understand. That's how people think about things in Chile when we did focus groups to plan the experiment. And so here is our kind of first set of interesting results, which compares earnings belief for typical graduates. So this is what students believe they'll earn relative to what graduates actually earn for each, for the colleges and majors that they're applying to. And so what you can see is that this is plotted against earnings for low earnings degrees. Students who are planning to enroll in those low earnings degrees are actually substantially overestimating their earnings post-graduation. Students planning to apply to high earning degrees are slightly underestimating them. Okay, and when we look within person, we also see a similar slope. So people are kind of, you know, particularly thinking about average earnings. If we looked at own earnings versus typical graduate earnings, so how much do individuals think they'll earn versus what typical graduates earn, people think their own earnings are about typical. So we see the same pattern there. They think they have this overconfidence or overestimate of earnings outcomes for these low performing degrees. For cost, actually, there really isn't that much of a difference in beliefs over cost versus actual costs relative to earnings. So here's what we see when we look at, I'm just going to plot the histogram for treated versus untreated individuals, students coming from low SES backgrounds and those coming from high SES backgrounds. And this is essentially the density of where they end up enrolling. So this is giving us the treatment effect of information on enrollment decisions. And what we can see for the low SES students is that most of them are actually enrolling in these very low earning, less selective degree programs. Essentially treatment cuts off a density of individuals who are applying to the very low earning programs and shifts them up towards kind of between the 50th and 90th percentile as far as earnings outcomes by college and major. We actually don't see very much impact for students from high SES backgrounds. This is actually the numeric outcomes. So this is kind of the OLS estimates of the treatment effects. And so overall, students who are treated enroll in 1.7% higher earning degrees than the control group, and that roughly doubles for low SES students, but 3.4% isn't huge. There's actually probably they could have gained about 10 times as much if they switched from on average, the degree they were planning to enroll in to the highest return degree that they would have qualified to get into.
Justine, I just want to kind of comment that if you can wrap, that'd be great.
Yep, I'm going to. In the medium run, essentially what we're going to see is that the low SES students stay longer in school. High SES students, we don't see much impact on their choices, but they do end up, if anything, finishing a little bit faster. So essentially, I'm going to skip this, but essentially what we're going to find is that we're going to estimate a model, basically a discrete choice model of college enrollment, where disclosure affects the precision of students' beliefs about earnings and costs. we find that treatment raises the weight students place on earnings by 32% and corresponds to a 43% reduction in noise to signal ratio, which for low SES students was 71%, so much higher than for high SES students. But this isn't a big enough effect to change demand by very much, because essentially non-earnings factors seem to be what drive choices for college students. So in summary, we use actual change in policy at scale to show that students enrolling in low earning programs overestimate earnings outcomes. Disclosure of earnings reduces enrollment in some of the worst performing programs, but the effects are really limited by strong preferences for non-earnings, non-cost attributes. Disclosure is probably worth it from a cost benefit perspective because it's cheap to enact and potentially over time becomes more powerful. But if we were thinking about really solving some of the problems with ex post regret of debt and student loans, regulation might be a quicker and more powerful force for accomplishing that policy goal. And I'll stop there.
I'm discussing these two papers, and let me first point out some commonalities and differences between the two papers. So both papers tackle questions of high policy relevance with randomized interventions. So the first paper by Hastings et al. Represents a very mature, polished, and long and meaty paper on a widely discussed policy intervention, namely earnings disclosures. And the RCT they conduct is directly motivated by the government's concern, and the novel findings they document are thus directly policy relevant. Now, the other paper is only available as a preliminary draft, but that doesn't subtract from the importance, because it examines a novel, thought-provoking aspect of human capital formation, namely the ability to sustain attention. And the authors, I think, argue convincingly that understanding this ability better and influencing it may help explain part of the education and earnings gap between rich and poor, and may help to close that gap. Now let me go to the first paper first in some detail. Now in this paper they ask two questions. Do students misperceive the earnings and costs of specific colleges and study programs, and as a consequence make bad choices, bad enrollment choices? And second, can the provision of college and major specific earnings and costs improve students' enrollment decisions and earnings outcomes? Now, what do they find? Well, they find huge mistakes in the perception of the earnings from, in particular, from low quality colleges and low quality majors. Those choosing the lowest earning degree programs hugely overestimate the earnings of past graduates of these programs, while their cost estimates are fairly accurate. Those choosing the highest earning degree programs somewhat underestimate the past earnings of students that went through these programs. Then they also argue that a Bayesian model that allows for noisy individual specific belief errors regarding the typical earnings outcome of a program explains this pattern, and they need two assumptions. So in the presentation there wasn't time to go into this, but in order to explain this with the Bayesian model, they have to have a general optimism bias in the model, and they have to assume that the variance of the individual specific belief is larger than the variance of the underlying distribution. And finally, the effect of the intervention is that the demand for the low quality programs decreases, and therefore the demand for better programs increases. So it's basically a reallocation of demand from low quality to higher quality programs. Actually these treatments effects, well, you can view them as sizable, and the paper argues a little bit in this direction, because the intervention raises the predicted earnings of low SES students by 3.2% of the control mean. And that is about similar to the effect of being assigned a teacher that is 2 standard deviations higher up in the value added distribution for 1 year. So when viewed from this perspective, in comparison with these other interventions, it's a sizable effect. In addition, they find that treated low SES students who choose better programs are 3.9% more likely to stay in school for at least 4 years. And, but however, they also, and that has been pointed out also in the presentation, the demand for the low performing colleges is still considerable. And that's attributed to strong preference for specific institutions and majors. So that's what they summarize under the term non-pecuniary characteristics of these programs that seem to play a big role. Now, let me make a few comments on these findings. I think the paper poses, the paper convincingly shows that the policy intervention has an effect, and it's a very well polished, informative, mature, and insightful paper on an important policy issue. I think it established a credible policy advice that governments should provide this information. However, at the same time, there are 2 puzzles that in the data of this paper. Puzzle 1 is that if you tell the low income students that primarily choose low quality colleges or low quality programs, that their beliefs are vastly off the truth, the response is actually quite small in a sense, because one would expect when people notice that they make these large errors that there's a bigger behavioral change. So this is really a puzzle for me. And that raises the question, what does it exactly mean when the authors speak of pecuniary characteristics that prevent the students from choosing better performing colleges? Is it the distance to their hometown? Is it the higher costs of living outside their village? Is it social network effects? So they don't want to lose their friends in their home villages. So unpacking the black box of what these non-pecuniary forces is, I think, a task for the future. And then there is the other big puzzle, in my view, is why are these beliefs so strongly off target, so to speak? Now they claim that, and that's true basically, their claim is true under their assumptions. They use a Bayesian model to explain beliefs, and that insinuates that these beliefs are somehow rational, but in fact, as an economist, we usually think when something is Bayesian, we might just stop here in explaining things further. However, the authors need a general optimism bias term to come to that conclusion, and they need these other assumptions on the different variances of in the individual beliefs versus the variances in the underlying distribution. And I ask myself whether the Bayesian approach really tells us what drives the incorrect beliefs of low SES students. My question is therefore, aren't there other more intuitive explanations, or for example, simply false or opaque claims by the schools that are more difficult to unveil for low SES individuals, or that are particularly targeted at them? So basically understanding where these wrong beliefs come from is, I think, pretty important in my view to make further progress in inducing students to avoid these low quality programs. And then my final question is, here I quote from the paper, our model allows disclosure to affect choice by increasing the precision of students' beliefs about earnings and costs. So that's the model. Now my question is, do you have direct empirical evidence that the intervention increases the precision? And that's it for the first paper. Now let me come to the second paper, Attention as Human Capital. And here the starting point was that poor individuals exhibit worse cognitive outcomes over a broad range of measures compared to rich individuals. And the paper focuses particularly on one, I believe, important cognitive aspect, namely the ability to sustain attention. And the paper documents basically that poorer individuals or low SES individuals exhibit larger performance declines over time in a broad range of tasks that go from school tests to workplace tasks to mental effort exerted in voting. Now, they go on with, and to put forward the following hypothesis. They claim that attention is at least partly a malleable skill that can be trained in schools. And because attention is required in almost all human activities, listening, reading, seeing, communication, doing, if you listen to me, you have to attend. So it's everywhere. Attention is, the ability to sustain attention is important in an extremely broad range of tasks. Therefore, we would expect really broad effects on a large range of tasks if you improve that skill. And that means that the training the persistence or sustainability of attention via a specific task, for example, via a math task or a reading task, should lead to far transfer effects on tasks that are unrelated to that specific task. So you can train, and that's what they do in one treatment arm, the persistence of attention. And that predicts far transfer effects on other things like math. In addition, the training or the intervention should lead to a reduction in the performance decline over time relative to untrained individuals. And it should not lead to an immediate performance advantage at the beginning of a task, of a far transfer task, because at the beginning, everybody is able to have the right amount of attention on average. But over time, the trained individuals are better able to sustain attention. So we should see only over time a reduction, so a better performance when you train this skill. And actually, before I come to the results, let me point out that the far transfer effects, if they exist, they are a really big thing. I mean, psychology would jump to the ceiling if they can prove far transfer effects. And there's a large literature in psychology, for example, on working memory training that tried to establish far transfer effects of working memory training. Working memory training is working memory is involved in basically almost anything we do. When you listen to me, you need your working memory, for example, and it has been very hard to show that. Now, let me come to their intervention. They have a control group, and in these control groups, students typically finish a small number of math questions during a study hall period. Teachers write these exercises typically on the board. And the students finish these exercises typically well ahead of time. So they only perform 5 to 10 minutes of exercise during a 30-minute study hall, and then they start talking to their neighbors or do not go on solving the remaining questions. In the math treatment, the students are provided with an adaptive software on a tablet which is customized for each student baseline achievement level. And in treatment games, they play interesting games that catch their attention. And the paper claims that both interventions here, they engage individuals in problem solving for an entire study hall period. So for the entire 30 minutes. So these are the treatments, and what are